This is the screencast for section 3.6, example 7. I almost forgot what section I was in. Comparing annual percentage yields. So this time, much like example 6, we're going to work to get an APY, an annual percentage yield, a basic percent from start to finish of the year that the bank account grew by. But this time, the situation gives us a little less information. Which investment is more attractive? One that pays 8.75% compounded quarterly, or another that pays 8.7% compounded monthly. So I have to compare the APYs of both of these functions because I don't know, or both of these bank accounts. I don't know which one is going to have a better APY. So over the course of the year, I don't know which one is going to earn a higher percent. One, because the 8.75 is compounded quarterly, but then the 8.7, a lower percentage rate, is actually compounded more, so that, I don't know, it's hard to tell. So I'm going to first look at the 8.75% compounded quarterly. Now, the initial investment is going to earn a rate of 8.75% compounded quarterly for 1 year. So I'm comparing that to the initial investment being compounded annually for 1 year. Very similar to the last example. Now, I don't know what the initial investment is, but if you look at my first step, if I divide both sides by P, that was bad. It actually doesn't matter what that initial investment is, because P will cancel out. I have 1 plus 0.0875 over 4 to the 4th equals 1 plus R. So now I can just simplify the left-hand side and subtract 1 from both sides to find out what my R value actually is. So I found that the 8.75% investment compounded quarterly has an APY of 9.04%. So now I got to see what the other investment produces as an APY to see if they earn more for the year or in total less for the year. So now I'm going to look at the, let's see, 8.7% compounded, this one's monthly. So now I don't have to worry about the initial setup because we already showed that that doesn't matter. So the investment is officially a 0.087 R over 12 to the 12th power. So we have 8.7% invested monthly. I'm trying to find out what annual interest rate that is. So I found out that the investment that is 8.7% interest compounded monthly produces an APY of 9.06%. So I'm only going to earn 9.04% at the end of the year for this first investment. The second investment, I'm earning 9.06%. Now I know what you're thinking. Well, it's like 0.02%. What does that matter? I'm sorry, but do you want more money or don't you want more money? Because I do. All right, then now try problem number 45 is the same exact setup. Which investment is more attractive? 5% compounded monthly or 5.1% compounded quarterly? So I'm going to set each of those up. The 5% compounded monthly account will has this set up for its overall resulting percentage, and then I set that equal to a basic annual, and I will solve for R. And then 5.1% compounded quarterly has this set up for its official end resulting percent, and I'll set that equal to a basic 1 plus a percentage setup to find out what its APY is. So as you can see, the difference between these two accounts is actually a little bit more than it was in example 7. The first account only produces 5.12% APY. The second account produces 5.2% APY. So at the end of the year, you're going to have more. You're going to have earned a higher interest rate with the second account that had a little higher interest but was compounded less.